Without these three concepts on your screen, you would almost always get the order of operations wrong, even if you memorize all the acronyms BIDMAS, BODMAS, PEMDAS. In this 8th lesson of the Basic Algebra in Full series, therefore, I'm going to walk you through these concepts from beginner levels all the way to mastery. Let's begin. To understand the order of operations, look at these expressions on your screen. On the left-hand side, you have 2 plus 5 plus 3 plus 9. What do you notice in this expression? All the operators are the same, plus, plus, plus. Now, what does this mean? It means that you have the freedom to do two things. First, you have the freedom to choose how you want to proceed in the simplification. You can either decide to do 2 plus 5 first, and then whatever answer you get, you add plus 3 and then plus 9. Or you could decide to do 5 plus 3 first, and then whatever answer you get, you add it to plus 9 or plus 2, and so many other combinations you can do. That's the first freedom you have. The second freedom you have is that you could rewrite this expression whichever way you wanted. You could say 2 plus 3 plus 9 plus 5, or 5 plus 3 plus 2 plus 9, or whatever combination you want. Now, this is because all the operators are the same. It makes no difference. Now, if you come over to the right-hand side of the screen, 2 plus 5 times 3 minus 9, you notice here that the operators are different. So that takes away your freedom of rewriting the expression the way you like. Say 2 times 3 plus 5 minus 9, or choosing where to begin. Say you want to begin with 2 plus 5 and then do this next, or begin here and do this next. No, you need a guideline to follow so that whatever process or steps you take to get an answer is exactly the same process or steps anyone anywhere in the world would also follow and get the answer. Those guidelines or protocols or processes is what we call the order of operations. Exactly where the name comes from, order. That is the process of how operators or operations should go. The order of operations in mathematics is that guideline that tells us that if we see an expression that has more than one type of operator, we should solve a particular operator first before the other. Now, the order of operations has been represented by so many acronyms, but these are the three most popular ones worldwide. BODMAS, commonly used in Africa, West Africa, the UK. PEMDAS, commonly used in the US and Canada. BIDMAS, commonly used in some parts of the UK as well. So right now, what we are going to do is we are going to talk briefly about these acronyms, and then you will see at some point why I said those three concepts at the beginning are the reasons why people still get order of operations wrong, why they still get wrong answers in the order of operations. You will also see that it is not because your acronym is wrong. The acronyms are not wrong. It is just your understanding of mathematics and the fact that the acronyms do not do justice to how you should use them. Now, what is the first item on the acronym? Here we have brackets. B for brackets. On PEMDAS, we have P for parentheses, and here we also have B for brackets. We all know that brackets and parentheses mean the same thing, so there's no need to talk much about that. So the order of operations is saying that when we see an expression, the first thing we should solve is the brackets. When we finish the brackets, then we go to the second one, which on the BODMAS list, it is orders. Then on PEMDAS, it is exponents, and on the BIDMAS, it is indices. We know from lesson 5 when we did powers that exponents and indices mean the same thing. Orders also mean the same thing. So you could also say powers. So powers, exponents, indices, orders, they all mean the same thing. In Africa and West Africa precisely, some people use of as the O in place of orders. Of is usually an algebraic term, a word problem term that means multiplication. But for the purpose of this lesson, ignore the of. Let us focus on what we see on the screen. Now, as we get to the third item on the BODMAS list, we start seeing confusion. Now, BODMAS tells us that we should do division first before multiplication. But PEMDAS says do multiplication first before division. Some people do paired mass, which is division before multiplication, just so that it will match with BODMAS. And of course, BIDMAS still says division before multiplication. This is exactly why I said those three concepts are very, very important to master before you talk about using the acronyms for order of operations. So let us freeze at this point on the BODMAS explanation and then go and talk about those three concepts first. Then we can come back to this BODMAS and it will make sense. The first concept is the operator ownership. This is not the first time we are mentioning this. In fact, for those who have been following this series from the first lesson, we've been mentioning operator ownership over and over again. So in this lesson, we are not going to spend so much time. We will just touch on it. If you need more information about it, go and watch the lesson 2. We talked so much about it there. So the operator ownership is just saying that every term or number in an expression owns an operator. And what operator does it own? It owns the operator to its left. So this 6 now owns this plus. This 7y owns the minus. And for 2y, which has no operator to its left, automatically there's a plus here. This is what the operator ownership is telling us. You need to know and remember this if you are going to succeed in anything you are doing in mathematics, not just the order of operations. This is also true even if it wasn't algebra. If we remove the letters, it is still the same thing. This is plus 6, minus 7, and plus 2. Never forget operator ownership. Now, concept 2. This concept 2 again is not new. We discussed it thoroughly in lesson 2 of this same series, so you can go back and watch it for better details, but we are mentioning it here again as a reminder. So what do we mean by operator siblingship? It means that in mathematics generally, all operators have two families, the plus family and the multiplication family. The plus family has plus and minus, which I called siblings, and the multiplication family has multiplication and division operators, which are also called siblings. So these are the two siblings. Now, in the multiplication family, I mentioned that powers, roots, surds are cousins or family members of the multiplication family. This information is very, very important if you are going to process anything in mathematics, and we will see why. Now, concept 3. This concept 3 is what we call reciprocal. It is saying that divided by something is the same thing as multiplied by 1 over that thing. We discussed this particular concept when we talked about multiplication and division in algebra, which is lesson 4. So if you need more information around this, you can go back and watch that video. So in other words, what I'm trying to say is that if we had 5 divided by 3, it is better you write it as 5 times 1 over 3. That is, change this divided by 3 to times 1 over 3. This is the third and very, very important concept. With these three concepts, order of operations becomes very, very easy. Now let's go back to the order of operations, the BODMAS display, and see how it changes everything. Now we are back here. Having gone through those three concepts, you now understand why this acronym BODMAS puts division before multiplication, why PEMDAS puts multiplication before division, because it doesn't really matter which one comes first. I could even change the BODMAS to BOMDAS, that is multiplication before division, or change the PEMDAS to PEDMAS. It makes no difference because these two operators are from the same family. It doesn't matter which one comes first. Anyone can go before the other because they are from the same family. Same goes with the addition and subtraction. They are from the same family, so it doesn't matter which one comes first. I could change the AS to SA and it will make absolutely no difference because they are both from the same family. So what we are saying in essence is that the order of operations does not have 6 rankings but 3. And what are these 3? Brackets or parentheses, the multiplication family, and then the addition family. So the first rank is the brackets or parentheses, the second rank is the multiplication family, and the third rank is the addition family. You may be wondering, why did I not put orders and exponents and powers as part of the multiplication family? Because they are actually part of the multiplication family. If you followed our lesson on lesson 4 and lesson 5, when we talked about multiplication and division in algebra, as well as powers, roots, and surds, you will see that we mentioned there that these are part of the multiplication family because they are derivatives of the multiplication family. And this also explains why schools in West Africa, like I mentioned before, put off which is a multiplication function in word problems, as part of orders. So you see how these things connect and how it makes it easy for us to use the order of operations. Now, some students may be watching this and be wondering, what of the left to right rule I have learnt or that I know? Your left to right rule does not contradict what I have done, but you do not need the left to right rule if you follow these three concepts I have explained. What does the left to right rule say? The left to right rule tries to justify why division and multiplication exchange places in both BODMAS and PEMDAS by saying that you should do whichever one you encounter first as you move through the expression from left to right. But if you already apply the operator ownership rule, you wouldn't need any left to right rule because the terms already own the operators to their left. So when you are simplifying, that operator that is to the left of that term will definitely be simplified with the term to the left of that operator as well. You will understand this better as we take examples, but this is just to mention it. The left to right rule, I recognize it, but you do not need it once you understand these concepts I've explained. Everything I've explained in this video is all you need to know to master the order of operations. One key reason why the left to right rule may be a problem later on, especially for advanced learners, is when you get to algebra proper, advanced algebra, where you have to combine a lot of terms that have variables. You find it difficult going left to right because you feel so rigid. But once you know the operator ownership rule, it makes it easier for you, become more flexible to be able to move terms around in expressions. You need that skill when you get to advanced algebra. That's why I'm sticking with the operator ownership rule instead of the left to right rule. Now, how does this apply to problem solving? That's exactly where we are going to next. Look at this question again. Let us now solve it. 2 plus 6 minus 7. With the concepts we've learnt, you don't need BODMAS in a question like this because all the operators are siblings. Plus and minus are siblings. They are from the same family. So BODMAS is irrelevant here. It's not going to change your answer. All you need to do is add and subtract as you see it or anyhow you like it that is convenient for you. So if we say 2 plus 6, that gives us 8. Then 8 minus 7 gives us 1. And that's the answer. Even if we go the other way, 6 minus 7 plus 2, 6 minus 7 is minus 1, and then minus 1 plus 2 is 1. So you see, whichever way you rearrange the question, the answer remains the same. Provided those three concepts are at the back of your mind, you already know them and you've mastered them very well. Now let's look at an example with the multiplication family and see if this is also true. Now look at this example, 8 times 6 divided by 4. If we follow the concepts we've learnt, we will first convert the division to reciprocal, which is times 1 over 4. So this becomes 8 times 6 times 1 over 4. Now, once you've done this, all the operators are the same. So it doesn't really matter the order you solve it. You still get the same answer. This is 4 here 1, 4 here 2. So 2 times 6 gives us 12. If you want to rearrange it to see if you get the same answer and write it as 8 times 1 over 4 times 6, you still get the same thing. 4 here 1, 4 here 2. 2 times 6 is 12. So you see how these concepts make simplification very easy. Now let us go to the major headaches students have, which is having expressions that have mixed operators, not just the ones that are from the same family. Now look at this example, 2 plus 7 times 6. Now this is the classic case where you have to apply BODMAS or PEMDAS or BIDMAS or the order of operations. Why? Because you are now dealing with operators that are from different families, plus and multiplication. Remember, we said if the operators are from the same family, don't bother yourself using BODMAS or PEMDAS or BIDMAS. You don't need it because you end up getting the same answer. So in this case, we have to use BODMAS. And what does BODMAS or PEMDAS tell us? It tells us that the multiplication family comes first. It means that we have to solve this multiplication first. And how do we do it? Again, those concepts must never leave your mind. This multiplication belongs to this 6. So we multiply what is directly beside the 6. We are not going to rearrange the expression. Remember what we said. If the operators are from different families, do not rearrange the expression. Leave it the way it is and solve it the way it is. 7 times 6 first, based on BODMAS, that gives us 42. Then we put the plus 2 here. So 2 plus 42 now gives us 44. And that becomes the answer. Now, for those who want to see how interconnected our lessons are, how mathematics is, which is what this channel is all about, you could put brackets here to show that this is the first one you are solving. And then when you get the answer 42, you now put your 2 here. This is based on the previous lesson we did. That's the last 2 lessons on removing brackets, in case you want to connect it to this. Let us now take an example that has as many of the operators or as many of the items on the BODMAS or PEMDAS list as possible, so that we can see how it applies. So in this example, all the operators are from different family. We have minus, plus, times, and division. Now remember what I said. Based on the concepts we've talked about, the first thing we will do is to convert this divided by 4 to multiplication, so that it will be easier for us to understand what we are doing. When we do that, it gives us this 5 minus 2 plus 3 times 6 times 1 over 4. We will now use the order of operations. Now, based on the order of operations, the multiplication family comes before the addition family, which means we are going to solve this first before we now factor in this. So that gives us, if we cancel this out, 2 into 4 give us 2, 2 into 6 here will give us 3. So if we multiply what is left, 3 times 3, 9, 9 over 2. So this gives us 5 minus 2 plus 9 over 2. Now, as you can see, all the operators now are from the same family. So we don't need any special BODMAS or PEMDAS. So what do? 5 minus 2 is 3, then plus 9 over 2. Now, based on the last lesson, if we want to add this further, it gives us 2 as the LCM. 2 into here, 2. 2 times 3, 6, plus 2 into 2, 1. 1 times 9, 9. So this gives us 15 over 2, which is the same thing as 7 whole number 1 over 2, and that becomes the answer. Again, if you are really into connecting the lessons, you could put your brackets here to show that this is what you solve first, and then you continue solving. But remember the laws of removing and creating brackets that we discussed when we did lesson 6. Please pay attention. If this was minus, you have to factor it into the bracket. Remember that. Now look at this example. This example is just to show you that even inside the bracket, sometimes you can have expressions that require BODMAS themselves. So this is like BODMAS or PEMDAS inside a BODMAS or PEMDAS. So in this situation, of course, based on the BODMAS law or PEMDAS law or order of operations, the brackets will come first. So you are going to simplify this first. How do you simplify this? All the operators are from different families, so it means that you need to do 5 times 2 first before you now add 3. So if we do that, this gives us 24 divided by bracket open 3 plus 5 times 2 is 10, then minus 5. So this now gives us 24 divided by, we solve the bracket again, 3 plus 10 is 13 minus 5. At this point, again, one of the concepts you discussed, very important, 2 of the concepts actually. Remember that this divided by belongs to the 13. It doesn't belong to 24. This is one mistake students make. It does not belong to 24. It belongs to 13. So when you are doing your reciprocal, you cannot do 1 over 24 times 13 minus 5. This would be absolutely wrong. So what you should do here is 24 times 1 over 13 minus 5. So using BODMAS again, it tells us to do the multiplication first before we are doing the minus. So this gives us 24 times 1 over 13 is 24 over 13. Then minus 5. Simplify it further. You will get minus 41 over 13. So this is just to show you that BODMAS and PEMDAS does not change even inside the brackets. We will now look at some examples, especially involving algebra and all. Then we wrap up the lesson. Now look at this first one. I intentionally put it to show you that all the lessons are connected. This has to do with collecting like terms, and all the operators are siblings. So you don't need BODMAS in this situation. All you need to do is collect like terms like this, which is 7m plus 2m minus 3n minus 5n. So this now gives us 9m minus 8n, and that becomes the final answer. We covered collecting like terms in details in lesson 2, so you can go back and watch it if you are not clear. Now look at this second one. 12y minus 4y is in the bracket, and based on order of operations, that's the first one we'll do. So 12y minus 4y gives us 8y. Then we put our divided by 4 plus 5y. Now we still have operators from different family. We have the divided by and we have the plus. And based on the order of operations, divided by should be done first. And don't forget, divided by belongs to the 4. So we are going to now say 8y times 1 over 4 plus 5y. Now if we cancel out 4, we go here 1. 4 into 8y will give us 2y. So what we will now have is 2y plus 5y, and if we simplify further, 2y plus 5y is 7y, and that becomes the final answer. Now look at this example. We will use the order of operations as usual. We have a bracket here, so that's where we'll start with. So this gives us 12 plus 6x times 4 minus 2 is 2. So this now becomes 2 raised to power 2 divided by 3x. Now the next on the list after brackets on the order of operations or parentheses is orders or powers, which is where this 2 raised to power 2 falls under. So we have to solve that next. So this gives us 12 plus 6x times 2 raised to power 2 is 4 divided by 3x. We still have to use order of operations because we have operators from different families here. So as usual, we will convert the division. So this is 12 plus 6x times 4 times 1 over 3x. We still have plus and multiplication, which are different families. So based on the order of operations, multiplication should come first. So let's put brackets here to show that we are doing all the multiplication first before we add 12 to it. X will cancel x up and down, and then 3 will go here 1, 3 will go into 6 to give us 2. So this now gives us 12 plus 2 times 4 is 8. So 12 plus 8. And that now gives us a final answer of 20. Now for this final one, we are going to look at the brackets first as usual based on the order of operations. And while we are doing that, we are still going to consider the order of operations even inside the brackets. So in this bracket, we see that we have divided by 3 squared here. So which means 3 squared will be simplified first because it is a power and it is the next in line in the order of operations. So this gives us 60 divided by 9 plus 14 times x plus same thing with second bracket. 8 squared is 64 minus 20 divided by 4 plus 15 divided by 5 times x minus 7x. Now still in the brackets, as you can see, the first bracket is 60 divided by 9 plus 14. The order of operations says do 60 divided by 9 first before we add 14. So that's exactly what to do. 60 divided by 9 is 60 over 9, then plus 14. We still leave the brackets because we will still try and simplify it if it is possible. Then times x plus the second bracket, 64 minus 20 divided by 4. Don't fall into the temptation of doing 64 minus 20 first, because based on the order of operation, we should do minus 20 divided by 4 first. And that's exactly what we'll do. So that gives us 64 minus 20 divided by 4 is 5. So that gives us 64 minus 5, bracket close, plus 15 divided by 5 times x minus 7x. Now we can simplify this 60 over 9 in the first bracket. 3 into 9 give us 3. 3 into 60 will give us 20. So this gives us 20 over 3 plus 14 times x plus 64 minus 5, 59. Then the bracket goes away, plus 15. The divided by 5, we'll change it to the reciprocal. Remember one of the concepts we discussed. So that gives us times 1 over 5 times x minus 7x. If we simplify this, it gives us 62 over 3. Then the bracket goes away, times x plus 59 plus 15 times 1 over 5 times x minus 7x. Now at this point, all the brackets are gone, but we still have to look at the order of operations. Why? Because the operators here are still from different families. Now, if you look at the order of operations now, the next there is multiplication. So we have to identify all the ones that own the multiplication operators, which is this, this, this. So to make it easier on our eyes, let us put brackets where the multiplications are. Let us now simplify those ones we've put brackets in because they are the next to be simplified. So if we do this, it will give us 62x over 3. The bracket of this will go away, plus 59. Then in this second bracket, something can cancel out. 5 can go here 1. 5 will go into 15 to give us 3. So that will now give us plus 3x minus 7x. If we simplify further, it gives us 62x over 3 plus 59 minus 4x. Now we can collect like terms because the x is on the numerator of the fraction of 62x over 3. So this will now give us 62x over 3 minus 4x plus 59. Now, based on the last lesson of algebraic fraction, we can make this minus 4x to be minus 4x over 1 so that we can add it with this fraction. This now gives us LCM of 3 into 3, 1 times 62x gives us 62x minus 3 here, 3 times 4x gives us 12x plus 59. So, if we now add the 62x minus 12x, that is 50x over 3 plus 59. And that becomes the final answer. Now, one final warning and clarification before we end the lesson. Look at this expression on your screen. Based on what we've talked about, this divided by should go below this way to give us 8 times 1 over 2 into 2 plus 2. Now, the problem with this question is that it is not clear if the division sign belongs to just the 2 or this entire thing. But based on mathematics, we know that anything with the brackets goes together. So the typical assumption should be that it is 8 divided by 2 into 2 plus 2. But this would have been avoided if the question was written this way in the first place. So the whole point I'm trying to make is that the order of operation wasn't created for chaos, but for order, as the name implies, order, so that we can have a unified way of solving problems. Therefore, anytime you are creating expressions, make sure that you create expressions that are clear to both you and anybody who is going to read it, including your examiners. Always make sure that your expressions, when you create them from your word problems, are as clear as possible. And how do you ensure they are clear? 1. Use brackets judiciously. Never be tired of using brackets. Secondly, always make sure that you convert any division to this bar, division bar. Division bar is a way to group terms to let us know these ones are above and these ones are below. Here are the try exercises as usual. We will release the solution shortly, but try them first. If you want more exercises, visit mathinfull.com. So many more for you to try. Our next lesson, which is the penultimate lesson for this series, will be on linear equations in one variable. This entire lesson is structured in levels. Check the description for the levels and what the levels mean so that you are not overwhelmed for those that are junior learners. Feel free to ask your questions in the comment section or send us a mail at ask@mathinfull.com. So it's a wrap on today's lesson, which is lesson 8 of the Basic Algebra in Full series. Keep studying and remember, in mathematics, it's all connected.